Hello students, welcome to my YouTube channel. In this video lecture, I am going to continue answering further questions from DME chapter Keith Williams. The questions I will be answering will be starting from question 31 ending question 40. So let's begin with question 31. Regarding the DME system, which is the true statement? The DME measures the phase difference between reference and variable signals to calculate distance. Utterly wrong. This belongs to phase difference is the principle followed by VOR. DME operates in the VHF frequency band. Wrong again. VOR operates in the frequency VHF band. Localizer operates in the frequency band. Your communication frequencies operate in the VHF band. Next, the transponder reply carrier frequency differs by 63 MHz from that of the interrogation signal. Yes. When passing overhead DME station, DME will indicate 0. Wrong. So first things first, I have explained this many times, the principle of operation of a DME in my previous video lectures. DME is based on secondary radar principle, right? Secondary radar principle means what? Transmitted frequency transmitted frequency and reception frequencies gonna be different. Okay, different. So for example, let's say this is your secondary radar on the ground. Here is your aircraft in the air. What will happen? This secondary radar on the ground becomes your interrogator. Aircraft becomes your transponder. Interrogator or secondary radar will transmit radio pulses in the direction of this target at a certain frequency 1030 MHz. Aircraft will reply to this interrogation pulses by transmitting another radio pulses in the direction of the secondary radar at what frequency? A frequency of 1090 MHz. Okay, so as you can see, interrogation frequency and reception frequencies are different. Similarly, in DME, which is based on secondary radar operation, aircraft will transmit an interrogation pulse. In case of DME, very important observation. In case of DME, your aircraft becomes the interrogator and the ground station becomes the transponder. So interrogator will transmit interrogation pulses at a particular frequency. Let's say for the sake of this example only, for simplicity of understanding, let's say it transmits at 100 megahertz. Correction, 1000 megahertz. So the ground transponder will wait for 50 microseconds and then retransmit radio pulses or reply pulses which at a frequency which will be different from this 1000 megahertz frequency by 63 megahertz. So the reply pulse will be equal to, let's say, 1063 megahertz. So as you can see, interrogation and reception frequencies are different. So the correct option here will be the transponder reply frequency differs by 63 megahertz. Delta states when passing overhead DME, the DME will indicate 0. That is wrong. When you directly pass overhead a DME station, the DME will still show range. The DME will still show slant range information on the display. But that slant range in this particular scenario will be nothing but, let's say aircraft is 36,000 feet above. So it will be equivalent to 6 nautical miles. So that slant range will nothing but be 6 nautical miles. But you will interpret this information as vertical distance of aircraft above the DME station, not the slant range. This is one unique case, remember. Next. Question 32. The design requirements for DME stipulate that at a range of 100 miles, when you are 100 miles away from a DME station, the error should not exceed what particular value? Now the ICAO specification states that DME must be accurate, DME information must be accurate, plus minus 0.25 nautical mile, plus 1.25 percentage of the range value. So plus minus 0.25 plus 1.25 divided by 100 into 100, plus minus 0.25 plus 1.25. So 1.25 plus 0.25 is 1.5. So it should not exceed a value of 1.5 nautical miles. A DME is at mean sea level. Aircraft is vertically above the station at flight level 360. So just now I took this example. When DME is at ground level and aircraft is vertically above it at 36,000 feet or 6 nautical miles. So the DME will show a slant range of how much? The DME indication will be equal to 6 nautical miles. Okay, but we know that aircraft is directly above the DME station. So that slant range information must be interpreted as vertical distance of aircraft above the DME. A DME is 1000 feet above mean sea level. So let's say this is your mean sea level. And the ground DME station is 1000 feet above it. Aircraft is at 37,000 feet above. Aircraft is 37,000 feet above. This is 1000. That means aircraft is only 36,000 feet above the DME. Okay. Now I'm drawing another diagram. Here is a DME station. Here is your aircraft. Aircraft is 36,000 feet above at a distance of horizontal distance of 15 nautical miles. 36,000 is nothing but 6 nautical miles, right? So slant range will be how much? Okay, they have to ask us DME reading. DME reading is nothing but slant range. Slant range will be 6 square plus 15 square. Pythagoras theorem. 36 plus 225. 36 plus 225. 61. So slant range will be square root of 261. 16 miles. So the correct option here will be 16 nautical miles. 35. In which situation will speed indications on DME most closely represent the ground speed of aircraft flying at flight level 440 or 44,000 feet? Now I have repeatedly said this in my previous video lectures. Ground speed indications will be accurate, will be accurate when aircraft, when first conditions, there are different conditions. Aircraft is directly flying towards or away from the DME station. Aircraft is far away from the DME station, and being far away, aircraft is at very low altitude such that the slant angle is minimum and slant range becomes closer to value of ground range. So here, let's select the options. When flying directly towards the station, this part is right. When tracking directly towards the station, this part is also right. When passing a beam, that is wrong. Passing a beam means, to pass a beam something means to fly across it, parallel to it. Okay, so you will not get accurate ground speed indication if you're flying across a DME station or parallel to it. Okay, so that means, let's say this is your, if this is your DME station here, this is the north direction. Your aircraft is flying due north. Aircraft is flying due north. Okay, so it is flying a beam parallel to this DME station instead of flying due north but towards the DME station. Okay, so when it is flying parallel, the indication will be wrong. When overhead the DME station, that is also wrong. So whenever aircraft is overhead a DME station like this, okay, so the slant range is nothing but the vertical distance of aircraft uh, above the DME station. So ground speed won't be calculated. How? Another, I will explain that. Now, how is ground speed calculated? Ground speed is nothing but distance. Ground speed is nothing but distance upon time. Now, the DME equipment measures rate of change in distance, that is slant distance, in a given time. Once you know that, once that measurement is done, ground speed is shown. Right? Simple distance, speed, distance, time formula. So as aircraft approaches this DME station, the slant range between aircraft and DME station will decrease, right? The slant range will decrease. Now the rate at which how fast this slant range decreases or how slow it decreases depends how quickly you are approaching this DME station. If you are approaching this DME station very fast, okay, at a very fast rate, that means the rate of change in slant distance between, okay, uh, between this DME station and your aircraft will decrease. The rate of closure increases if your speed is fast, right? So by checking or measuring this rate of change in slant distance against a time, you can get to know your ground speed. But when your aircraft is directly above this DME station, you cannot know, you can't know ground speed because the rate of change of distance or slant range is zero when you are directly above the DME station. It is not zero when you are flying towards the station or going away from it, but it is zero when you are directly above the station. So that's why ground speed won't be possible there. Alpha and Bravo are correct. And now look at the option A. You are 10 nautical miles away from the station. You are 100 nautical miles away from the station. So the conditions are you should be flying directly towards or away from the station, okay. Two, you should be as far away from the DME station as possible. So here 100 nautical mile is farther than 10 nautical miles. So correct option will be option Bravo. Ground speed indication will be correct in this second case compared to the first one. Next. The time taken for the transmission of an interrogation pulse is 2000 microseconds. Slant range is equal to speed of light multiplied by time interval divided by 2. The time interval here is 2000 microseconds. Now this 2000 microseconds is inclusive of 50 microseconds, right? What is this 50 microseconds? Whenever the ground DME station transponder receives interrogation pulses from the aircraft, it waits for 50 seconds and then it retransmits the reply pulses to aircraft DME receiver. So we will have to subtract this 50 microseconds from this 2000 in order to get our accurate range between aircraft and the DME station. So this is 1950 microseconds. So range will be speed of light 3 into 10 raised to 8 meter per second, time 1950 microseconds multiplied by 10 raised to minus 6 seconds divided by 2. So 10 raised to 2 into 1.5 into 1950. So 1950 into 1.5 is 2925. So land range is 2925 into 10 raised to 2 meter or 292.5 kilometer or 292.5 divided by 1.85, that is 158 nautical miles. So select that option which is closest to this value. 37. Aircraft passes overhead a DME again at 12,000 feet. So let's say if this is your DME station and your aircraft is directly overhead at what altitude? At 12,000 feet. So this will be interpreted or this will be shown as a slant range of how much? 2 nautical miles. 12,000 is nothing but 12,000 divided by 6,000, that is 2 nautical miles. Bravo is the correct option. 38. When flying 6,000 feet above ground level, DME shows 5 miles. What is the horizontal distance from aircraft to the DME? So here we have to find out horizontal distance. So pay attention to the question. So this is the triangle. Here is your DME. Here is your aircraft. 6,000 feet. 6,000 feet is 1 nautical mile, right? Horizontal distance unknown. DME shows slant range. So slant range is 5. So 5 square Pythagoras, 1 square plus x square, 5 minus 1, 25 minus 1, 24. So x is root of 24, which is approximately 5 nautical miles. 4.8 accurate value or approximately 5. Next, DME operates in UHF band and uses two frequencies. So DME is based on secondary radar like explained before, and secondary radar uses one frequency for for interrogation, one for interrogation and another for reply, that is transponding. In case of DME, interrogation and transponding frequencies are different by 63 megahertz. Okay. Very important question, practical. Aircraft is at flight level 30,000, speed 300 knots, and it is about to pass overhead a DME station. So it is very close to a DME station, but it is not overhead yet. The DME receiver is capable of determining ground speed 1 minute before the overhead. You are just 1 minute away from the DME station. What will be the speed and distance indication respectively? Okay, so look at this notes that I wrote here. Ground speed indications will be accurate when aircraft is directly flying towards or away from the DME station. So in this question given, it is flying towards the DME station and it is only 1 minute away from it. So condition 1 is satisfied. Second is aircraft should be far away from the station. Aircraft should be very far away from the station in order to get an accurate ground speed reading. But in the question here, aircraft is just 1 minute away. So it is very close to the DME station. So let's say if this is your DME station here on the ground, aircraft is just 1 minute away from it somewhere here. So in that case, the slant range will be this, like this. This will be the slant range. This will be the height and this will be the ground range. So slant range will be much more than ground range. This is height of your aircraft. Okay, so DME speed and distance indication will be what? Now DME ground speed indication will be accurate, like mentioned here, if and only if your aircraft is very far away from the station. Okay, in this case you are only 1 minute away, that means ground speed indication will be inaccurate. So what is the ground speed given to us? 300 knots. So the ground speed indication shown to you will be inaccurate, meaning it will not be exactly 300, it will be somewhat less than 300. So either option Bravo or option Delta, either of them. Next, distance. Now you are at flight level 300. Flight level 300 or 30,000 feet is nothing but 5 nautical miles. Now 5 nautical miles will be indicated only and only when your aircraft is directly overhead this DME station. It's directly overhead this DME station. But as given in the question, aircraft is not directly overhead yet. It is 1 minute away from it. It is 1 minute away from it. So in that case, the slant range will not be equal to 5 nautical miles. Okay, it will be somewhat more than that. So the only option here is, the only suitable option will be option Delta, because option Bravo says 5 miles. 5 miles will only be possible if an aircraft is directly overhead, but in the question it is away from it by 1 minute. So the only option is 7 nautical miles, more than 5 miles. So Delta is the correct option. So whatever theory we have learned, we have to apply it here next. Okay. So this concludes our lecture. I'll stop here. The next 10 questions will be done in the next lecture. I hope you have understood these 10 questions very well. Practice them on your own without looking for the explanation or any help. So, and that will boost your confidence. Okay, it will enhance your preparation level. I wish you all the best again. Share this video with your friends, please. Let them know about this particular channel, this particular video lecture, and hit the like button if you have liked this video lecture. I will be glad if you do that. All the best and see you next time.